Okay, YouTube, I think I've got this figured out. So I designed some little standoffs here for the tube. So these are 3D printed parts. So I just made a cylinder 30 millimeter diameter with a 30 millimeter half circle taken out of the top. Put a hole in the middle just to save on filament. And then it's about 1 inch or 25 millimeters high at the points, which puts this end about 10 millimeters high at the bottom. So what I did was try to make the seam on the tube equal to the shade here. Of course, I've got the tube upside down. It's just easier to test fit. And these are just glued in, so I kind of spaced them out roughly 1/3 of the way around. And I just put the glue on the back side of the standoffs and then set the tube down over it to get them to line up, and left them with a little bit of weight on for a while for the glue to set. And then I tried to get it roughly centered in the opening there. And I spaced the standoffs out so that these vent holes I don't think will be covered. Yeah, because I've got one here. So there's one there. This one is right over here on the side, so I'm right there. And then I think this one is just on the side of that vent. So I tried to stay away from these ventilation holes. And then speaking of ventilation, what I did was drill about 7 little holes here on both sides of the switch just to let heat come up out of here. And then I put the driver down here. I took it out of the little plastic case that it came in, and I just glued the 2 capacitors. So this is your output capacitor, and then on the other end is the input capacitor. Those were a little bit higher than the rest of the circuits. Figure that way it'll get adequate cooling, and then I can keep all the connectors down here. So I've got to feed the wires back in here and then get it hooked up to the switch. So yeah, then I'll put the connector or the wire harness on the light right about there. A little bit of wire management once I put this together, but that way I can connect those up. And then the final thing I just figured out was how to hold the tube in there. I was initially thinking I would use some light adhesive, and then I thought I might try some Velcro on here, put a piece of Velcro in each of these standoffs. But I think I can get by with a little metal tab. And so this is where the magnifying lens goes, and it's held in with these clips. So I've got my little metal tab and the screw. So again, the lens is held down here with these little fingers, 3 places around there. I'll just drop the tube in there, but the idea is I can just fold these 3 tabs over. So this should hold the tube in there pretty good. I can just bend these 3 tabs over. If I ever need to replace this or take it out, I can just bend those tabs back. This is a pretty heavy-duty lens. It's solid glass, probably a good 3/4 inch thick, 20 millimeters or so. It's a substantial lens. Yeah, you gotta definitely put it in first. Okay, I think that's gonna work. Just put those in there. I still have to take the tube out so I can get the hardware back in here, get all the wiring done on the switch. But yeah, I can just bend those tabs out of the way. Okay, and that picture was the wiring in there, showing you the switch and everything. Really tight in there, trying to get everything installed, because like I say, the wires are on the top, and then the hardware is on the bottom, and then when you put the tube in, you can't see anything. It's all tucked in there, but I think this works really nice now. And wow, yeah, that's a nice light. Let's see, I do get a little bit of light coming up through these holes. Oh, it's coming off of the inside of the reflector. So Yeah, the switch is still a little flaky. There's a couple of positions. That one works. That one doesn't. But at least I can turn it off now if I want to. Usually what I do is I just leave this on because it's a nice light in itself, and then I just turn the whole 12-volt system on or off. And now we got a decent amount of light, and I like this color better too. It's natural white. I think the other LEDs I had were cool white, so they were really bluish color, and I like this a lot better. Matches the other lights I have in the rooms. That way it won't look out of place. One of the problems I had before with the other LEDs, they were so light that the balance on this was off. You would put the lamp down and it would rise back up because it wasn't heavy enough. But now I've got about the same weight as the old fluorescent tube, and it stays where you put it, so that's another benefit. Wow, that's nice. Yeah, so now I can get back to work on my battery modules, because I find this magnifying Worklight makes these really easy to solder. My fuse wire is really small. For soldering this size wire, you really need a magnifier to see what you're doing, because it's so tiny, it's almost invisible, because this is 30 AWG wire, and it's so small that you can't see what you're doing. I needed to get this fixed so I could work on these, because I'm going to be building a lot of these. Without light and magnification, it's really hard to do this, because you've got to run individual wires from each pair of cells up to the bus bar. So there's 10 fuse wires, and then you flip it over, and then you run the 10 other wires down here. These are larger gauge. I think I use 18 gauge on the bottom. Bright, no flicker, and no buzzing. So that's good in my book. So anyway, yeah, I'll put links to the parts that I used here in the video description. You can check those out. No affiliation, just I found a good supplier that has some decent parts. I also got some other lights for my Forerunner, and I'll be doing video on those, so stay tuned for that. They had a couple of really neat cargo lamp solutions that I want to put in the truck for camping, but this one was for the workbench and my magnified Worklight, so kept at 12 volts. If you have any questions about that, post up in the comment section below. And as always, thanks for watching.